Alright, well, welcome back. Another practice problem, this time making use of a nice flow chart. Again, coming from Brown's Chemistry, the Central Science. So we're walking through how do we classify different types of matter. There's this nice flow chart in the textbook that you can sort of follow along with to get to an answer if you're given a particular example of matter. We'll let the screen catch up here. So we're given a nice sample exercise. We'll let that load. Distinguishing among elements, compounds, and mixtures. That white box that remains, I put that there intentionally. So I like this format where they give us a practice problem with the answer, and then they give us yet another practice problem just to hone in the skill. So in the one they walk us through, white gold contains gold and a quote-unquote white metal, such as palladium. Two samples of white gold, they differ in the relative amounts of gold and palladium they contain. Both samples are uniform in composition throughout, and they want us to use figure 1.9 to classify said white gold. So we have an example of how to walk through a flow chart. Zoom out a bit. Sometimes OneNote's a little frustrating with how it throws up the picture. I'd like to get it all in frame for us. There we go. That looks like that'll do nicely. So, switch over to pen mode so we can trace where we are. So we're told white gold. Obviously we start off, it has to be matter. It contains gold and the white metal, and we're told that both samples are uniform in composition throughout, so you have two instances of white gold, so you need at least two to make the comparison, and both of them are uniform throughout, so yes, we follow this flow path, which means that the material is going to be homogeneous or homogeneous, depending on how you like to say it. Then the next question, does it have a variable composition? Okay, well, look at what information are we given. The material is uniform throughout, it's homogeneous. However, the two samples differ in the relative amounts of gold and palladium. And that just means, just throwing out some numbers here, say one sample's maybe 50% gold, 50% palladium. Say the other one's maybe 30% gold, 70% palladium. They're both mixtures of gold and palladium, but the relative amounts of each material are different between the two samples. Therefore, we see that it does have a variable composition, so we arrive at the conclusion that white gold is a homogeneous mixture. Okay? So a nice example of how to walk down the path and classify a substance, white gold. You've probably seen that in jewelry stores, whatnot. So an interesting real life example. Well, all life is matter, right? So then our practice exercise here. Aspirin is composed of 60% carbon, 4.5% hydrogen, and 35.5% oxygen by mass, regardless of its source. Use the same figure to classify aspirin. I like that they have that little bit regardless of its source. If you extracted aspirin from some sort of natural product, perhaps, or whether you bought it at one grocery store or another, aspirin is aspirin is aspirin, if you will. So let's start through. Let's walk down the path. It's got to be matter. We're talking about it. Regardless of the source, if you get aspirin from one place, aspirin from another, the two samples are uniformly going to be 60% carbon, 4.5% hydrogen, and 35.5% oxygen. So yes, we have sample uniformity between at least two samples. And then regardless of the samples, we see no variability in composition. because it's just 60%. We have the elemental breakdown here, so we follow this path of no. So we know that aspirin is a pure substance. Can it be separated into simpler substances? And in this sense, yes. So taken together, if you take this mixture of 60% carbon, 4.5% hydrogen, 35.5% oxygen, in this particular ratio and with the particular chemical bonds that we've got, yes, collectively it makes aspirin, but you could obviously, if you could somehow divvy out the carbon, separate away the hydrogen, separate out the oxygen, you can break it down further. So yes, it can be separated into simpler substances, thereby it is a compound. And if I can move this block, let's see if it's going to let me do it. There it goes. Well, kinda. Not as smooth or pretty as I was perhaps hoping that would be. Goodness gracious. Let's try that again. Wow. Note to self, don't do that again in OneNote. Yeah, that'll suffice. And so if we want to zoom in on our answer here, just to corroborate what we said earlier, yes, aspirin is a compound. It has constant composition, and it can be separated into several elements. So, interesting application of the flowchart. Two nice examples there, seeing different types of matter.